We are starting with a new topic here, and the topic is definite integral. Now, in this topic, definite integral, what actually we are doing is we will evaluate the integral the way we had already evaluated. We have learned how to evaluate integrals in indefinite integration in the previous topic. So what you have learned there, you are going to do exactly same way, but this time you are going to do it in an interval. You are going to integrate in an interval. So this is what I have written. You will integrate the function of x, you will integrate function of x with respect to x in some interval. So say the interval is alpha to beta. So here I wrote a to b, it can be alpha to beta. Okay. So the only change that you notice is this. See, anyways, in the earlier topic, you had already learned how to integrate f of x dx. You had understood the meaning of integral f of x dx. In this topic, what is extra happening? That you are going to integrate in the interval alpha to beta. This alpha is known as lower limit. Alpha is the lower limit of integral. This is lower limit, and here it is upper limit. I have written here, like here a is lower limit and b is upper limit. So if you have a question in your mind that how is that going to happen, for that you will have to wait for a few minutes. It's going to unfold at proper time. So right now I'll take the topic ahead by saying that as per our syllabus, keeping our syllabus in mind, this complete topic can be divided into three parts. We can divide complete topic in three parts. Now, what are those three parts? One by one, we'll see. See, part one is, in part one, we are going to see all the problems similar to problems from indefinite integration, but in an interval. What are we going to see? We are going to see problems similar to problems from indefinite integration, but in this topic it's going to be in an interval. It simply means that suppose you have solved 800 problems in indefinite integration. You have solved in the previous topic, say you have solved 800 problems. So here in definite integration, in this topic, you can once again solve those 800 problems by taking some interval, by taking some proper interval. By considering some proper interval, you can again solve those problems. For example, suppose I write here integration of sine square x dx. Now you know the method of integrating sine square x dx. You have already done this problem in the earlier topic of indefinite integration. If I put sine square x dx, if I put a limit, say pi by 4 to pi by 2, now this becomes a problem from definite integration. Okay, so this is what is going to be the first. This is going to be the first part of our definite integral problems. What the first part is, all the questions that we have solved in indefinite integration, similar questions we will have here, but this time we are going to have them in an interval. We are going to have them in an interval. For example, if I ask you integrate x cube plus 3x square plus 7x plus 2 dx, you can definitely integrate this because you know how to integrate. But if I say in the interval minus 2 to 2, okay, so everything that you had done in the previous topic, you would do it once again, but this time you have interval. See, the method of integration of this function would not change. Just because you have lower limit and upper limit, just because you have an interval here, the method by which you integrate this, that will not change. You will apply exactly same ideas which you have learned. But in addition to that, there is one more additional step you will have to apply. which I am going to tell you. Okay, one more additional step we will be applying. So this is first part. This is first part of our integration, definite integration. Then the second part is rather more important, and that is problems based on properties of definite integration. So see here, part 2. Part 2 is properties of definite integration, properties of definite integration, DI, definite integrals, and problems based on properties and problems based on properties. This is the second part. And the third and the last part here is integration part 3. Part 3 here is definite integration, definite integration as limit of a sum, limit of a sum. This we are going to see. Okay, so please copy this. So let us learn how to evaluate a definite integral problem. So here I write, if integral f of x dx is g of x plus c. Suppose you have a function of x and its integral with respect to x is g of x plus c. Then integral f of x dx in the interval a to b will be, see, what you have written here is, you have written integral f of x dx is g of x plus c. Now what is happening in the next step? You are integrating the same function in the interval a to b. So what you will do, you will write here g of x plus c, you will put it in a bracket, and here you will write a to b. You will write g of x plus c. Okay, integral f of x dx is g of x plus c, so that would not change. It is still g of x plus c. You will enclose this in a bracket and then write here at the bottom of the bracket, to the right extreme you write a and up you write b. What is next step you do? Now this, inside the bracket, wherever you notice that you have x, wherever x is there, like here you got x, okay, so that x you will replace by upper limit. You will replace x by upper limit. When you do that, you get g of b plus c. Okay, g of b plus cu. This is first step. After integration, this is first step. What you did here inside the bracket, wherever you notice x, you substitute upper limit. Then you will subtract this by putting by the expression which you get after you substitute a in place of x. So what is next? First you substituted, in place of x you substituted b. Now you substitute a, so you will get g of a plus c. This is what you will get. So what exactly you have here? You have the difference of two numbers. You have the difference of two numbers. The first number you got when you substituted x as upper limit. Okay, so you got this. The second expression you got when you substituted, you replaced x by lower limit. Okay, so this step we call it as upper limit minus lower limit. This step we will call it as upper limit minus lower limit. Okay, so see what we get next. Now I open this bracket. When I open the bracket, I get here g of b plus c minus g of a minus c. And I notice that the c will get cancelled. C gets cancelled. And because the c is getting cancelled, I'm left with g of b minus g of a. Okay. So what I got a to b f of x dx is g of b minus g of a. Students, this problem we solved in general. I'm noticing that this constant of integration is getting cancelled here. See, I notice that constant of integration is getting cancelled. Plus c minus c, it gets cancelled. So this makes me realize that whenever I'm integrating in an interval, it makes me realize, because this c is getting cancelled, it makes me conclude that if I'm integrating in an interval, I shouldn't be writing constant of integration. Okay, if I'm integrating in an interval, there is no need to add constant of integration. Why? Because even if we are adding it, anyways, it is going to get cancelled finally. So we here decide, we make a decision that we are not going to add constant of integration when we notice that the integral is within an interval. That is, if I notice that it is a definite integral, I will not add constant of integration. Okay, so let's have an example here. So here, so suppose I have to integrate cos of x in the interval 0 to pi by 2. Cos of x dx in the interval 0 to pi by 2. What I will do, I know integration of cos x is sin x plus c, but I will not write plus c. I will write only sin x, and then I will write 0 to pi by 2. What is next step? The next step is upper limit minus lower limit. That is, wherever x I have in this wherever x is there, I will put pi by 2. So I'll get here sine pi by 2. X is replaced by upper limit, minus x is replaced by lower limit, 0. So sine pi by 2 is 1, sine 0 is 0. So the final answer is 1. Okay. So this is an example I did for you. Please copy this. We will go ahead after this. Please copy it. So here we have a definite integral question to be evaluated. We have to integrate x plus 1 upon root x. The given function is x plus 1 upon root x in the interval 1 to 9. Now this question is from part 1. Why part 1? Because for integration of this question, see, for integrating this particular function, I'm not applying any new thing that I'm not applying any new ideas or concept. It is something that I am applying it from the earlier knowledge. It's only this interval thing, that 1 to 9 is a new thing over here, or else everything is from indefinite integration. So here I will write, see, how do I integrate? I write here, I write here 1 to 9 and split this x root x. So I get here x upon root x plus 1 upon root x dx. In the next step, I get here x upon root x is root x. So I get here 1 upon 9 root x plus 1 upon root x dx. So the next step is, I write here I equals to, I write separate integral now. So it is 1 to 9 root x dx plus 1 to 9 1 upon root x dx. Now you know this root x is x raised to half. Root x is x raised to half. So here x raised to half. Okay, so integration of x raised to half is, we will write x raised to half plus 1. It is x raised to n type upon half plus 1, and close the whole thing in a bracket, right? 1 to 9 and plus 1 upon root x. Integration of 1 upon root x is 2 root x. 2 root x, and then write 1 to 9. Okay. Now the next step, here I'm going to get 3 by 2. Now this 3 by 2 is a constant, and this 3 by 2 I will write outside. Okay, this 3 by 2 can be written outside. No need to keep such a constant like this 3 by 2, and this 2, this can be written outside. Okay, so Here I get 3 by 2, so that will become 2 by 3 because it is in denominator. So 3 by 2 will become 2 by 3, and I get here x raised to 3 by 2, 1 to 9. Same way here, 2 is a constant. It can be written out, and root x 1 to 9. Now from here, here I will apply the evaluation of upper limit minus lower limit. Wherever x I will put 9. Wherever x I will put 9. Then wherever x I will put 1. So it will get me 2 by 3. X raised to 3 by 2 it is. So 9 raised to 3 by 2 minus 1 raised to 3 by 2 plus 2. And here I get square root of 9 minus square root of 1. Square root of 9 minus square root of 1. So here you will, when you substitute upper limit, you get square root of 9 minus square root of 1. So the next step is we will get here, we will get 2 by 3. See, I'll get here, I'm using another color. So I'll get here 2 by 3. See, this is 9 raised to 3 by 2. Now 9 I can write 3 square. 3 square raised to 3 by 2 minus 1 raised to 3 by 2. You know 1 raised to any number is 1. Plus 2 times, and square root of 9 is 3. Square root of 9 is 3 minus 1. So you get here 2 by 3, and this 2 and 2 cancel, so you get 3 cube minus 1 plus 2 into 2. That is, you get 2 by 3. 3 cube is 27. 27 minus 1 is 26 plus 4. So you get I equals to 52 upon 3 plus 4. That is 64 upon 3. This is your answer. Okay. Question number 5. We have to evaluate 3 to 5 1 over square root of 2x plus 3 minus 2x minus 3 dx. Okay. So what I will do? I will do exactly what I did when I solved such a problem in indefinite integration. If you remember, we had done such a problem earlier as well. So here we will not do anything extra. We will do only that. But finally, we will have to apply upper limit minus lower limit step in order to get the final answer. So let's begin. So for integration, what we will do, we will rationalize the denominator. Okay. So I will suggest you to start solving with me. So here 2x plus 3 minus root of 2x minus 3 into square root of 2x plus 3 plus square root of 2x minus 3. I am rationalizing the denominator, okay? And here square root of 2x plus 3 plus square root of 2x minus 3 dx. Okay? So you have now 3 to 5, and see, you have a minus b, a plus b. So denominator will be a square minus b square. So you will have square of this. So 2x plus 3 minus square of this, that is 2x minus 3. And numerator you have square root of, square root of 2x plus 3 plus square root of 2x minus 3 dx. This is what you will have. Okay. Now when you open the bracket, see what will happen. When you open the bracket, what will you get? when you open the bracket, you will get I equals to 3 to 5, and see this 2x will cancel, minus 2x plus 2x cancels, and you get 3 plus 3 in the denominator, you will get 6. And here you have square root of 2x plus 3 plus square root of 2x minus 3 dx. So now 1 upon 6, you will have 1 upon 6 outside, 3 to 5, and square root of 2x plus 3 plus 2x minus 3 dx. Now I will write separate integral. So I equals to 1 upon 6, and 1 upon 6 is outside. You will write separate integral for these two. So that is 3 to 5. See, every question, every step you have to keep writing 3 to 5, 3 to 5. Okay. Every step you will have to keep writing that 3 to 5, and this is 2x plus 3 dx plus 3 to 5, and here you have square root of 2x minus 3 dx, and then bracket completes. So you have I equals to 1 upon 6, and this is square root of 2x plus 3. Now integration, 2x plus 3 under square root is 2x plus 3 raised to half. So integration of this will be 2x plus 3 raised to half plus 1 upon half plus 1, and since x coefficient is 2, so you will divide by 2, and then you will put this whole thing inside a bracket and write 3 to 5. Okay, see what I did. I know that this square root of 2x plus 3 is nothing but, it is nothing but, it is 2x plus 3 raised to half. It is nothing but 2x plus 3 raised to half it is. Okay. So, and here also this is nothing but 2x plus 3 raised to half. So this is raised to half, and here also it is raised to half. So integration of 2x plus 3 raised to half is 2x plus 3 raised to half plus 1 upon half plus 1. And why this 2? Because x coefficient is 2, so I have to divide by 2. Plus, now see here what I will have. I'll have here 2x minus 3 raised to half plus 1, divide by half plus 1, and then multiply 2 here, and then write here 3 to 5, and enclose this whole thing inside a bracket. Okay. Now next step you will have, see this is 3 by 2. So this 2 and 2 cancels. You will get here 3 by 2. You will get here 3 by 2, and here also you will get 3 by 2. What will happen? 3 by 2. So that 2 will cancel with this 2. So basically you will get 3 only. So here you get I equals to, 1 upon 6, and 1 upon 6, and 2x plus 3 raised to 3 by 2, divide by 3, and this is 3 to 5. Don't solve in haste. Okay, have patience. If you try to complete it faster, you will end up doing a disaster. So 2x minus 3 raised to 3 by 2, and here down also you have 3 by 2, up 3 by 2 into 2, so that 2 will cancel, and 3. This is also 5 to 3 to 5. Now in next step, this 3 will come out. See here, 3 here and 3 here. This 3, 1 upon 3 will be outside. So this outside, it will become 1 over 18. Okay. So I have I equals to 1 over 18, and this is 2x plus 3, 2x plus 3 raised to 3 by 2, 3 to 5, 2x plus 3, 2x plus 3 raised to 3 by 2, 3 to 5, plus 2x plus 3 raised to, sorry, it is 2x minus 3, 2x minus 3 raised to 3 by 2, and 3 to 5. Put this in a bracket. Okay. Now I go for upper limit minus lower limit. Wherever x I have wherever x I have, wherever x I see, I will put first 5. So I get here 1 over 18. Inside the bracket, I get 2 into 5. 2 into 5 plus 3, that is 13. 13 raised to 3 by 2 minus 2 into 3. 9 raised to 3 by 2. This is upper limit minus lower limit for this part. I repeat again what I did. Where I have x, I will put upper limit, which is 5. So 2 into 5 is 10. 10 plus 3 is 13. 13 raised to 3 by 2 minus wherever x, I will put 3, lower limit. 2 into 3 is 6. 6 plus 3, 9. 9 raised to 3 by 2. This is upper limit minus lower limit for the first part. Plus, now I will put upper limit minus lower limit for the second part here. You know what? Where x, right? 5. So 2 into 5 is 10. 10 minus 3 is 7. So you have 7 raised to 3 by 2. 7 raised to 3 by 2. Now subtract after putting the lower limit. So 6 minus 3 is 3. 3 raised to 3 by 2. So you have 1 over 18 and 13 raised to 3 by 2. This is 13 raised to 3 by 2 is 13 raised to half the whole cube. You understand? So what is it? It is square root of 13 the whole cube. It is square root of 13 the whole cube. So root 13 cube minus this is root 9 cube. Root of 9 cube, square root of 9 cube, the first bracket, plus this is square root of 7 cube, root square root of 7 cube minus square root of 3 cube. Okay, so this will get me 1 over 18 and you can check here. This is 13 root 3. 13 root 3 minus root 9 into root 9. This is root 9 into root 9. So this is 9 root 3 plus this is 7 root 3. Root 7 into root 7 into root 7. So 7 root 3 minus 3 root 3. Minus 3 root 3. So you get here 1 over 18, 13 root 13. This is not 3 here, it is 7. It is 7 here. So I get here 13 root 13 plus 7 root 7 minus 12 root 13. And this is final answer. This is the final answer. Yeah, students, I committed a mistake here. Okay, this is here. I'm sorry for that. So this whole thing will change. This is square root of 9 is 3. So 3 cube is 27. 3 cube is 27. So that's it. This is your answer. You can't do anything more. 3 cube. Square root of 9 is 27. Square root of 9 is 3. So 3 cube is 27. This is the final answer. That's it.